This section discusses why this concept is important. We have several energy sources that we rely on to supply our power grids with electricity. These sources include solar energy, wind energy, the burning of fuels, hydropower, and more. Our society has developed many technologies to successfully convert that energy into forms we can harness and use more efficiently. When discussing our societal efforts toward using renewable energy sources, we tend to focus most of our attention on the inputs and outputs, not the processes by which we convert one into the other. So we tend to appreciate renewable and non-renewable energy sources, including harvested sunlight and wind energy, alongside fuels like natural gas and oil. We also appreciate the outputs for power generation, which almost exclusively involve energy supplied to our electric grids. But technologies we currently have at our disposal to convert these inputs into energy outputs are imperfect and vary in their respective efficiencies. It's important to appreciate that no perfectly efficient power generation technology currently exists. This module covers our existing power generation technologies alongside their capabilities and limits to demonstrate how far we've come and where we are. These technologies vary by their design, the types of energies they operate on and produce, and other factors relating to their performance. They can also vary in their functions and can either directly or indirectly influence the efficiency of the power generation process. We look at traditional energy generation technologies, including engines, turbines, and boilers, which are used directly to generate electricity. We examine how these technologies have been adapted over time to generate electricity from newer alternative and renewable energy sources. This module looks at power generation on a more nuts and bolts level and gives us more context to begin quantifying and comparing our options for the future. This includes exploring more recent power generation technologies, including waste heat recovery systems that indirectly boost plant efficiency by minimizing and possibly one day eliminating the energy lost as we convert one or multiple sources into another. One leading strategy for boosting plant efficiency is installing these systems to recover that lost heat and using them to reduce the plant's fuel requirements. Towards the end of this module, we take a closer look at power generation efficiency and learn how to assess the performance of waste heat recovery and cogeneration systems, as well as how we can use those numbers to make strategic cost-saving decisions for an operation. The module will conclude with life cycle assessment exercises designed to grasp the inputs and outputs required at every step of a wind turbine and a concentrated solar power (CSP) plant's life. This skill module discusses the topics shown here. You may also be interested in the skill modules shown here.